my customers. Consider the wind turbine. It's very different from the solar panels, which people are more familiar with. Because solar panels are more stable. And then solar panels are stable, but wind turbines are dynamic. They follow the wind and then they rotate. So the consideration when you try to choose a wind turbine, you have to be more, get more considered points. Try to be cautious, especially for the installation location. It's very important. Try to make your wind turbine can make it work for you for a long, long time. Malaysia is similar to Taiwan, surrounded by ocean. So more or less, the wind is corrosive. Plus a lot of rain. In Taiwan, we have typhoon. So for all the points you have to consider, then you can choose a wind turbine to work for you for a long time. Basically, if you go into the market, you can find two major types of the wind turbine. The first one is called vertical. They rotate it like this. The second one is called horizontal. They rotate it like this. What's the major difference? Okay, I'm going to compare the advantage and disadvantage for you. For the vertical type manufacturer, they usually say, I can accept wind from 360 degrees because the three blades, they are 360 degrees separated. Okay, that is true. But in the meantime, this advantage is also their disadvantage. Why? Assume the wind is blowing here. So this blade was driven by the wind. Try to rotate. But the other two blades is coming up. So they stop the wind. So there are a lot of resistance in this design. They cannot rotate it real quickly. And what is the difference? I believe someone has a technical background. Why they can generate electricity? Because they can cut and produce magnetic flux within a short time. If the rotation is not quick enough, the flux generation will be less. So that means your electricity generation will be less efficient. For this type, we rotate it this way. So when the wind blows, it can accelerate the blade rotation and it goes like this. So it will generate more electricity for you. So basically, if you want electricity efficiency, we highly recommend horizontal type. And this model has been shown internationally, world famous. In year 2008, the G8 summit was conducted in Hokkaido, Japan. In front of the hall this year, in addition to 8 countries' national flag, this air dolphin was shown right in front of the 8 nations' national flag. Of course, this get a lot of good awards, but we don't want to introduce too much. The specification of this wind turbine is like this. The rated power is 1 kilowatt. The maximum power output is 4,000 kilowatt for on-grid type. The off-grid type is 2.3 kilowatt. There is an important figures. If you try to choose a wind turbine, you have to know what is the cut-in speed of your wind turbine. The wind turbine sales might sell to you, how good our wind turbine is, but don't be cheated. You just ask him a question. What is your cut-in speed? And what is the cut-out speed? These two figures give a good definition of the performance of a good wind turbine, because this wind speed is when start to generate power. This wind speed defines when to stop generating power. So from start generation to stop generation, these two figures will define a good wind turbine. So no matter if you go to the market and the wind turbine sales say how good our wind turbine is, blah, 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 don't be treated. Just ask him these questions. Okay? And normally, you can find vertical type. The power generation period is like this, 3 meters per second up to 50 meters per second. But this will go from 2.5 to 50 meters per second. Because in Taiwan we have typhoon, so we have to design our wind turbine can accommodate very strong typhoon. This one is the classification of typhoon. The lightest typhoon started from 7.2 meters per second up to 32.6 meters per second. And the middle typhoon is slow typhoon. And we can continue our electricity generation up to 50 meters per second. And this is a benchmark already for all the available wind turbine we can see in Taiwan. Now everyone is, after my introduction, everybody can focus on the cut-in speed and cut-out speed here. And the second thing you should pay attention to is the weight. It's a 90 kilogram for 400 watts. You see the rest, it's 135 for 1.8 kilowatt. So it's a huge difference. I will skip this design. Horizontal type, the efficiency is high. But what is the disadvantage? People will say to us, we will cause a lot of noise. Noise like this. So we try to learn from the nature. We observe an animal called owl. This animal only be active in the night. No main forest. This species can survive up to now. This means when they fly, there is totally no noise. So we try to take a feather and use the telescope to see the structure of this feather. We notice there is a stripe and a shape like this. So we use this point and design into our blades. We try to imitate the wisdom of nature and to reduce the noise level of our wind turbine. And this is our basic theory. When we make it a real product and put in the real wind field to test, the horizontal versus axis is the decibel, the noise level, the vertical type, and the horizontal is the wind speed. As you can see, the red triangle is the background noise from the wind. The blue point is our wind turbine noise. We always cope, different speed, we also cope with the background wind noise. So in terms, we have 6 meters per second at 48 dB, and 12.5 meters per second, we have only 52 dB. So yeah, this means our imitation is quite successful. I think that's probably, my time is running out, so